is when you have more than one y, you have to do implicit. If you have a mixed up y, so it's not in y equals, you could do implicit or get y by itself and then do that. So we're going to do both for this question only. So this one here, it says finding a derivative using implicit differentiation. So here we don't have y equals. Up until now, everything has always been in y equals. We agree? This is not. However, it does have only one single y, so we can isolate the y, correct? But if there's like a y and a y squared embedded with some x's, you can't take the y out, okay? This one you can. So we're going to solve it by normal, getting into y first. So we have xy minus 4 equals 0. We're going to add 4. Xy equals 4. And then we divide by x. What did I tell you when you have a monomial on the bottom? You can bring it to the top and do power rule, right? So this is x to the 1. I can rewrite it as 4x to the negative 1. If you don't spot that, you're going to have to do quotient rule, which is g times f prime minus f times g prime over g squared. And you get the same answer. It's just substantially longer. So y prime equals negative 4 x to the negative 2, which they'll rewrite as negative 4 over x squared. They'll drop the 2 to the bottom. Now, implicit. If we do it in the implicit way, what you need to know is, and I'm going to show the long way as to why it works this way, but whenever you do the derivative of anything, it's with respect to x, right? All the ones we've done. If it's like one of those distance, speed, time questions, and it was t, then it would be with respect to t. It's whatever the variable is that's sitting in the x position, okay? So in this case, the variable in the x position is dx. So they want you to find dy over dx, okay? So what I need to spot first is these two are multiplied. When two things are multiplied, how do I do the derivative of them? Product. So, and I'm showing the long way. I'm not going to do this after, but I'm going to prove why. So this is an f. This is my g. What's the derivative of x? 1. It's 1. Now what you don't realize is the derivative of x is actually 1, and behind it every single time you're going like this. You're going dx over dx, because you're doing the variable x with respect to x. But what does dx divided by dx cause? A 1, so we're never ever writing it. But every single time you're taking the derivative of an x, it's with respect to x. You see there's an x on the bottom? It's with respect to x, but the variable that we're taking it of is x. So it'd be dx over dx, which is a 1. So that's why we never write it. Do you see that? Okay, what's going to happen with the y, though? So if we're doing the derivative of y, so this is f prime, we'll say, is 1. And g prime is going to be 1. But behind it, I'm going to have not dx over dx, I'm going to have dy over dx. And does that go away? No. So when you take the derivative of anything but the x, you're going to end up with a dy dx behind it.
Oh, is that why, like, sometimes they look different than just d over dx?
Yeah.
Okay.
Yeah.
This whole
So,
time I thought they were just playing games.
No, d over dx is just saying take the derivative with respect to x.
Okay.
But we've always only had x's. So technically behind every single derivative, we should have written dx over dx, but it's the same as writing ln e. It just goes away. So we haven't been writing it. But now that we have some y's in here, we have to actually follow behind with dy dx. So we're going to do the quotient rule. And by quotient, I mean product rule. So we're going to do f, which is x, times g prime, which is 1 dy over dx. Do I have to write the 1? No. So it's just going to be dy over dx. And what is dy over dx the same as? Y prime, right? Tangent slope, right? So this just is the actual first derivative, right? If I have something set equal to dy over dx, I have the first derivative of it. Do you agree? We have like dy over dx, instead of putting y prime, if I put dy over dx equals, I have the first derivative. We agree? Okay. So we have f times g prime plus g, which is y, times f prime, which is 1 dx over dx, which canceled. And then what's the derivative of 4?
No.
Nothing. And then, so I can just write plus 0, or I can write nothing, equals 0. You see that? So I did product rule for the x and the y. The derivative of 4 is nothing. Derivative of 0 is nothing. Now, what do they want in the end? They want y prime equals answer. Or in this case, dy over dx equals answer. We agree? So I need to get dy over dx by itself. So the first step of implicit is always to just do the derivative of what it is. So you might be doing product rules, you might be doing chain, whatever. Do the derivative of what it is, and then your second step is to get dy d over x by itself, and once you have that, you have the answer. You're done. You have the first derivative. Dy over dx equals that, right? That's it. So the hardest part of this question is people don't spot a product rule. They'll just go derivative of x, derivative of y, and then it'll be wrong. That's the first problem. Second problem is they forget when they take the derivative of a y, they have dy d over x, dy over dx left over. So how do I get dy over dx by itself? Move, yeah. So I'm going to get x bracket dy over dx equals negative y, and then I would divide by x. Now some might say, the great thing about implicit is when it's a big, beefy implicit, you're actually done when you get to here. However, this one doesn't match that one, does it? Because I have a y in it. So if I actually get y by itself up here, xy equals 4y equals 4 over x. Do you agree? So I can put a 4 over x in for the y. So I can go dy over dx equals negative 4 over x divided by x, which is the same as negative 4 over x, times 1 over x, which is the same as the answer over there. So like I said, if there's a single y, like this one has just one single y, we agree? Do you see that? Just one y in the whole entire equation. I will never pick implicit unless I'm forced. I will solve for y and just do my normal math. It's when you have more than one y, you can't do that. So there's these problems for this. We're going to flip over.
So did you say that as like if they ask you for dy over dx, usually leave it as a thing, unless you're like.
The answer doesn't match it.
Okay.
And in
Like,
this,
for a response, you could just leave it as.
for one like this, you're always going to, for the single ones like this, you're always going to have to get it into this. Because they're not expecting you to do this implicitly. They want you to do this properly. Solve for y. It has a single y, right? What's up? What's the matter? You're all giving me the same look. Okay. Sandy, you do? Okay, okay. You're all giving me the look if you don't know what you're doing. But I will carry on because you're telling me to. Okay. Everyone good? No, there's still people writing. Yeah. Because the equation was just equal to 0. If the equation was equal to 7, then we put still a 0 because the derivative of 7 would be 0. So with implicit, our first step always is to see if there's a single y. If there's a single y, do not do implicit. Kibosh implicit. Yeah, there we go. Now we find it. Y to divide by x. Because it's negative y over x.
And y is equal to 4.
So I have to move this x over, so I divided by x, right? And then I have to replace the y, so I went up here.
Yeah, below that.
So I went and replaced the y. I know I'm explaining, guys. I'm working through. I started up early instead of later, where you're like, no, higher. No, 2 steps higher. So I started early. Now you guys are like, no, lower. Can't win with you people. So we got the division of x
What do you mean by that?
by dividing. We're going into the movie, aren't we? Yes, we are. We're going to the movie. Okay, so it's because there's an x down there, but the y is up here, right, Sandy? So we had to actually replace the y. So I went up here to this equation, and I solved for y. And when I solved for y, I got y equals 4 over x. So I could take this y, I could toss it out, and I could replace it with 4 over x.
Yeah.
But it had a negative already, right? So it was negative 4 over x, but I still have a division of x here. because I replaced this with this. And then this is this division sign, and then this is x.
Oh, okay.
Because I just replaced the y, and then I wrote it sideways because it was a fraction. That's all. I could have written it like this, but then that's hard to deal with. Okay. Now we're getting to real implicit. So this one, you could solve for y. There is only one single y. You could. You would get 2x minus 3x squared divided by 4, and then the square root of that. And then you'd have to do chain rule. And then you'd have to do some other stuff and simplify it, and then boom, get down to the bottom. Okay? But when they have like a y squared or something embedded, they often will have implicit, and they'll just leave the y be the y, but we could replace the y in the end with that ugly radical as well. Okay. The ugly radical? Yes. I'm sorry, radical.
Does it mean if it's true?
Yeah, Connor, yes. Yeah. Still mean, might be facts, still mean. Sorry, radical. I'm sorry, radical.
Accept that. It's gross.
Well, what's ugly? Really? Like, it's really our own thoughts on how the radical looks.
This is concretely ugly.
Okay. All right. So, we're going to first, it wants us to find dy over dx, so we're just going to go ahead and actually just differentiate it. Okay? Now, none of these have product rules in it. This is a really nice one, actually. There's no product rules in it. You're like, yeah, sure. It is. It's a really pretty one, in my mind. Maybe not in everyone's, but in mine, it's pretty. Okay? So, how do we do the derivative of 3x squared? It would be 6x, and then technically, dx over dx. Correct? Or the d over dx would go away. Like, technically, when you take the derivative, when there's more than one variable, we're always going like this behind it. We agree? But dx over dx is a 1, so that's why we don't write it. Make sense? Okay. Then we do the next one. Plus 8y, and then behind it is dy over dx. Equals, and what's the derivative of 2x? 2, and then technically dx over dx. I'm just doing this to prove a point. Just like when I write the law E every single time. Prove a point. So those go away, and that's the reason why the y gets a dy over dx, but the x's don't have it because it's dx over dx. And that's just 1. Okay? So my first step was always differentiate. Second step is always to what? Get dy d over x by itself. Because if I have dy over dx equals answer, I have the first derivative. Correct? So, I'm going to rewrite this because it looks stupid. A 6x plus 8y dy over dx equals 2. So my goal is to get this bad boy by itself. So what am I going to do? Subtract 6x. Okay, carry on. What do we do next?
Minus 6x.
Minus 6x. And then divide by 8y. Now, we are done. However, if you get to this point and it does not match, you could have screwed up. That's one thing. But if you didn't screw up, what they could have done is they could have then went up here and isolated for y. So they could have went 4y squared equals 2. I'm not going to actually carry through. I'm just showing you. 2x minus 3x squared. Divide by 4. And then they would take the square root of it. And then all they would do is just take that and replace it and call it a day. Yeah, and times it by 8.
And would they ever rationalize?
No. Might in more advanced calculus, but not in this one. But most often it's just left with the y. My point to saying that to you is if you get an answer and you know you're right, like there wasn't a lot of math we had to do here where we could have screwed up. Product rule you could screw up. Quotient rule you can screw up. Here it's kind of your more basic ones. So you know you're right, but it doesn't match. It's probably because they solved for y and then inputted the y in. And how will you know that? The answer does not have a y. mind-blowing, right? Your answer has a y, their answer doesn't. They input y. Boom. Drop the mic. Yes.
Is there bonus questions on our unit test? This is a valid question.
Well, I guess you're going to have to find out when you get it.
Good answer.
Yeah, well, I think so. You probably want to know too.
No, I actually have forgotten about reading tests.
Oh, no, the Wi-Fi is going.
I don't need Wi-Fi. I'm recording on my
We
phone.
can't just do it.
I don't need Wi-Fi right now.
We gotta go home.
I only upload after. You know you're recording this gibberish of what you guys are talking. You sound like a whole bunch of dumb students. No, we can't record. There's no Wi-Fi.
No, I never said we can't record it, then you can't upload.
Sound dumb. That's what you guys do, okay? And now it's recorded for, you know, purposes of later dates.
This left called love relaunch the dog.
You said your own name. All right. Okay. Good talk. All right. So the next part, it says here, shh, if you look, we have 3x squared. We have 3x squared plus 4y squared equals 2x. Oh my goodness, it's the same equation, Batman. Okay. Now we want to find an equation of a tangent line. These are really easy because once you have the slope, first derivative, you have the slope. So the first derivative was just this. I'm going to rewrite it. dy over dx, which equals m tangent, equals 2 minus 6x over 8y. And one day, if you keep doing math classes, you guys are going to look back at this time and be like, wow, I wish I could go back to that. As you're like on the fourth board of writing a proof that you don't understand any of it. Truth. Okay. Every single person always wants to go back to the earlier stuff. So we have 2 minus 6x over 8y. We agree that's m tangent. What did we do to find the actual tangent when they gave us a point?
You put that point in.
We plugged in the x, correct? But now we're just going to plug in the x and y. Because we have an x and a y. Rocket science, not so much. Now, reminding yourself, if I give you an x but not a y, or I give you a y but not an x, how do I get the other one? Plug it back into the original, you get your other one, boom, you can still get your tangent, right? So I don't have to give you the x and the y. But I did, because I'm nice. So let's carry on. They're ugly fractions, but you're fine. Okay. The fractions work with these numbers, so don't like. I know, and they work really nice with this. I wasn't talking about the fraction spot, but okay. Minus 6 times 1/2 over 8 times negative a quarter. So we're going to get 2 minus 3, which is negative 1, over 8 times negative a quarter, which is negative 2. So now I want an equation of a tangent. So where do we go after this? Every single time. Yeah, at point slope form. Y minus y1 equals m times x minus x1. And then we can move it to whatever form they have. Might have this form, and we don't have to move it at all. So we're going to do y minus negative, so we get plus a quarter, equals 1/2 x minus a half. Okay, we're going to work as a team to try and get the fractions to go away.
Times 8 times 4. Times 4.
So many numbers.
Well,
So,
I was gonna say
so we can put, yeah. So we can put the number into the fraction, into the bracket first. So we're going to get y plus a quarter equals 1/2 x minus 1/4. So that could be an answer. So we could times every single term by 4, and it would get rid of the fraction problem. Yeah.
Can you like subtract 1/4 so you only have 2 fractions?
Yeah, we could subtract the, but then, yeah.
You still have to do the 4.
Yeah. I'm just going to do it without it being a fraction, because most people will not make more mistakes that way. So I just get rid of the fractions right off like that. But you can absolutely do that. So We're going to multiply by 4, multiply by 4, multiply by 4, multiply by 4, and I do it to every term so you don't screw up. That one's gone, that one's gone. This one is a 2. So we would be left with 4y plus 1 equals 2x minus 1. Subtract my 1. 4y equals 2x minus 2. And then divide by 4. We're getting our fractions back. So it doesn't matter. Whatever route you go. And sometimes they just stop at the 4y plus 2x equal. You know, you've seen it before where the option is actually 4y minus 2x equals negative 2. Sometimes they have it in that form. It just, what form do you get it in? The one that matches the multiple choice. Other than that, you could have just left it in the first one and boxed it if it was a written response. Right? You could go right here and say, I'm done. So if it's a multiple choice, you have to have it in the form that they have it in. And sometimes their multiple choices is just in this form too. And how do you know? Because it looks like point slope form. Yes?
What is the format of our test? Is like
The whole thing's no calculator, and it's all AP questions. Good luck, Godspeed. I made it harder than the AP test, and then I'm not curving it. But I'm going to give you normal calculus credit, so I think it's fine. It's fair.
Thank you. Is it
Totally
the
fair.
lucky bucks?
You get a calculator the whole time. It's just a normal Shame, it's just calculator the whole time. There's no. The AP test is half not calculator, half calculator. Your calculus test is calculator.
like all multiple choice.
It's the same as it's. I don't really put the numeric, so it's just multiple choice and written.
What's the stuff that we've done AP and like what's the stuff that we've done normal?
All of it is normal. The only thing that isn't going to be on your test that is AP that isn't in the curriculum is trig inverse, which we're doing tomorrow. Everything else is normal calculus. It's just that the AP questions are harder. Like if you go look at the AP questions, they're way harder than just a basic like the derivative of x squared sine 4x. Like, that's a basic question. AP will give you like a part of an F and a part of a G and then some craziness. Hola, señorita.
Hi, just look at what you're doing.
Just calculus. It's easy. Don't worry about it. MBD. It's easy, guys. It's because I'm such a good teacher. It's so easy.
You have the slope of the tangent.
Now, because I'm so good, this question is going to be so easy. I'm very humble. All right. So, what do we notice on the left-hand side? That is something to notice. Not where I was going, but it is true. Okay, E to the y. Yes. Gold star. Okay. So it's a product rule. So we are going to have an F and a G. So off to the side, we're going to write our F prime, we're going to write our G prime, we're going to do product rule on that side. Okay? Okay. So F prime, this is my F, this is my G. What's the derivative of e to the y? E to the y, ln e, times 1, those all go away, and then dy over dx. So the only thing that happens different here, when it's an e to the x, the derivative is e to the x. Ooh. Thanks for puberty, it's fine. When it's ln e. Because ln e is 1. If you type ln e into your calculator, the answer is 1. So like if you have a ln 2 or a ln 4 or a ln anything but e, it doesn't go away. So ln e goes away when it's ln e. Okay, so the derivative of e to the y is e to the y, but we have to remember to go dy dx whenever we take the derivative of a y. If you're like, I'm never going to remember that. Whenever you do implicit, just go dy over dx, and when you take the derivative of x, go dx over dx and cancel it off. Like, just do that, and you'll never make a mistake, because you won't forget the y, because you're also doing the x's. Okay? So, for example, cos x, it starts with a c, so it's negative. What's the derivative of cos? Negative sine x. Now, because it's just cos x, it's negative sine x, and it's technically, I'm going to show you all the work, it's negative sine x, and it's technically multiplied by 1, because I take the derivative of what's in the bracket. And then it's technically multiplied by dx over dx. However, all of this is garbage and it goes away. So it's literally just sine x. So that's why the derivative of cos x is just negative sine x, because you're multiplying by 1, but that doesn't matter. And then you're multiplying by dx over dx, but that doesn't matter. So that's why it's always just negative sine x. Does that make sense? Okay, so let's start. Okay, so we go f, which is e to the y, g prime, which is negative sine x, plus g, which is cos x, times f prime, which is e to the y, and then dy over dx, and I'm running out of room. And you have to keep going. You do the derivative of the whole thing. The other side's really easy. What's the derivative of x? 1 dx over dx. It just cancels off. And then what's the derivative of 1? Nothing. So the right-hand side just equals 1. Does that make sense? Did I lose anyone? Everyone here? Okay. So the first step is to derive. The second step is to get dy over dx by itself, right? Whenever I have just one y, which I've so far had only one y, it's been nice. So I just have to get this bad boy by itself. So I'm going to have to, this is actually subtracted, right? It's negative sine x e to the y. So I can add it over. So I'm going to get cos x e to the y dy over dx equals 1 plus sine x e to the y, or e to the y sine x. It doesn't matter what order you put this in. But I'm adding it over because this negative sign can come to the front always. Then what do I do? Divide by cos x e to the y. So I get dy over dx. Now, if you were allotted your calculator, we will be able to do the next step that way to check it, but we're also going to do it algebraically. So this is it. I want you to find y prime. So that's it. No, it's the plus sign. This is 1 plus this. Yeah, but it's 1 plus that. So this is like the head, the body, and the feet of a human. And you just cut its toes off. Vicious. So the only way we can do that, Alexa, is if the whole top is multiplied and the whole bottom. Or I can take a GCF out of both terms in the top and then cancel. So like if this had an e to the y and that had an e to the y, and I can take the e to the y out. Yeah. Okay. Now we want an equation of the tangent line. What did we find currently? M tangent. We found the first derivative. So we have M tangent and our x and our y. And they often will give you like a 0. And why did I tell you they give you a 0 if there's no calculator section? Because e to the 0 is just 1. Okay? And the trig you should be able to do at sine 0 and cos 0. And if you can't get your trig circle, unit circle back, bring it back. You need to memorize it. Memorize. 1 plus sine of 0, e to the 0, over cos 0. And these are easy trig ones, the zeros. E to the 0. So e to the zeros become 1s. Yeah, so here's your normal point, right? It's at 1 and 0, and it's Calgary Stampede, correct? So cos of 0 is 1, sine of 0 is 0. So I'm going to get M tangent equals 1 plus 0, so 1, over 1, so it is 1. Nicest tangent slope ever. And then we want the equation of a tangent. So what are we going to do? y minus 0 equals 1 times x minus 0. So it's just y equals x. It's the identity line, the one that the inverse reflects on. Fun times.
Oh, the Wi-Fi's back.
Oh, good. I was scared that I wouldn't be able to record without my Wi-Fi. Okay. I know. Then down here. And we're going to flip over. That's how it works. Okay. It's one question less.
But I might see it.
I haven't done all of this, I'm trying to remember.
Okay. I want you guys to find y prime for this, and then we're going to find y double prime. Go. Okay, so for this question, instead of writing dy over dx, I'm going to write y prime, because it's the same thing, right? I'm just proving a point that you can do it either way, and it doesn't matter, and you're not wrong. So this one here wants us to find y prime, not dy over dx, so I'm going to use the y prime form. If it asks me to do dy over dx, and when I take the derivative of y, I'm going to write dy over dx, okay? If it says y prime, when I take the derivative of y, I'm just going to write a y prime, because y prime equals dy over dx. They're just different forms, different notations. And it depends really which one your prof likes better is what's going to happen. So I kind of stick with both, just so you can kind of see the difference. Okay. So, just so you know, dy over dx, if you take the derivative of it, is going to become d2y over dx squared. That's how they're going to write it. I don't know why they put the 2 in the middle of the 2. That's how they do it. Yeah, that's what they do. Okay. Just so you know that the second derivative, y double prime, will be that, if they wrote it in that notation. Okay? So, the derivative of y squared is 2y and then dy over dx, but I'm going to write y prime, because it's the same thing. And then minus x squared is minus 2x, and technically it would be dx over dx, so that's why I did that form first, because when you see dx over dx, it makes more sense. Then people will try and write x prime, but there's no such thing. And then it equals, derivative of 5 is 0. Now I'm going to tell you where people where people go wrong on this question often, and I'll even do it by accident, is you're going through it mindlessly and you're not really thinking, and you'll leave the 5 as a 5 instead of turning it to a 0. So just make sure you don't do that. Okay? So our next goal is to get y prime by itself. So we're going to get 2y, y prime equals 2x. Divide by 2y. And then y prime equals x over y. We agree? Now, if we want the second derivative of this, we just have to take the derivative of that. So what does y prime turn into when you take the derivative of y prime? It would be d2y over dx squared, or y double prime. The derivative, because we're just going to differentiate this. Yeah. So if we take the derivative of y prime, it turns to y double prime, right? We've done that before. When we take the first derivative, go to the second derivative, it becomes y double prime. Next derivative turns to y triple prime. If you're using dx over dy, your dx over dy turns into this, d2y over dx squared. So if you had used dy's over dx, which you would have, because I didn't make y prime, you would have d2y over dx squared now. Okay? And then what's this? What do we have to do? Quotient rule. So this is f, this is g. F prime is 1, g prime is 1 y prime. Or for you, if you were using dy over dx, 1 dy over dx. It's the same thing. Okay? So we're going to get g, which is y, times f prime, which is 1, minus f, which is x, times g prime, which is y prime, over y squared. Now this is where the problem is going to happen. We have to get, the first one we get y prime by itself. We agree? For the first derivative? The second derivative, we'd have to get y double prime by itself, correct? It already is. So yay. The problem is this isn't going to match an answer. So I'm going to star this one here, because this is what people forget often. You need to put y prime in that spot. They won't have the answer with y prime. You need to put y prime in that spot. And what does y prime equal? X over y. It's right here. So to find the second derivative of an implicit, you have to end up in the very last step putting your first derivative into it, because you're going to end up with a y prime. And this isn't wrong, it just won't be there. They'll put the y prime in every single time. So we're going to get y double prime equals y minus x times x over y squared. So we get y double prime equals y minus x squared over y squared. And they won't stop here. They'll put the top in as a full fraction. So what do I have to do? Multiply by y, because I have to get a common denominator of y in the top, right? So the left one, I'm going to have to multiply by y. Oh my gosh. There we go. It is. It's quite thick. Okay. So we're going to get y squared minus x squared over y. Oh my goodness, I have a fraction in my numerator. What happens when I have a fraction in my numerator or a fraction in my denominator? I immediately write them out side by side, which we did in our proofs, correct? So I'm going to write it as y squared minus x squared over y, which is the numerator, divided by y squared, which is y squared minus x squared over y times 1 over y squared. So what do we actually get?
Y squared minus x squared over y cubed.
And that's the answer they're going to have. And just so you know, I already posted the worked out solutions to the AP, I think, yesterday, just so I didn't forget. Okay, this is just a fun one. This is something you already know how to do. You do. Fun, it is. This is about as fun as it gets. Okay, so what do we have to do to this first one in order to find the derivative of it?
It's x to 1 half.
X to the 1/2.
1 half x to the negative 1.
So it would be 1/2 x to the negative 1/2 done. So this isn't implicit. We're just bringing this back. Just a little reminder. You try B, C, D. Quick. So then this one is going to be equal to d over du of u to the third. So that's going to equal 1/3 u to the negative 2/3, which they might write the negative 2/3 in the bottom. So 1/3 u to the 2/3. And then what is u to the 2/3? The cube root of u squared. They can write it like that. Remember the 3 comes in front as the index? Taught that in grade 10. Again.
I do.
Plus we've done it a whole bunch in grade 12. Yeah. So the 3 comes in front as the index on the root symbol, and then the number on top stays underneath. So the 3 just drops in front. Okay, this one is going to be 5/2 x to the 3/2. So you're just subtracting 2/2 from it. And then x to the 3/2 is the same as the square root. I could put a 2 here, but it'd be wasting my time. And then x cubed. What do I have to do for d? There's a monomial on the bottom.
You have to bring s up by
Making it negative,
and
yeah.
then it's I think s times 3 times that. Well, then you have to like do something.
So you get negative 3/2 s to the Subtract 1 from that, negative 5 halves, which they can drop it to the bottom. And then that's just the square root of S5.
Technically, the one is multiplying by the, like, it's multiplying the s to the negative 3 halves by 1, right? Like when you break it up through the whole.
Yeah.
Okay, so if you really want to divide it out as literally just, like, 'cause I got the same thing, it's just.
Yeah, just way more work.
Okay, I don't know sometimes when I'm supposed to.
When you're doing product rule with F being just a number, like 2, 7, 8, 4, don't do product rule. You can just do power.
They're always, are most likely gonna have the last answer as the answer in multiple choice. Like, are we gonna do a friend with it?
Most of the time, but it just depends. Sometimes they do, sometimes they don't. All right, I'm going to get you guys, we're going to do one of the AP practice problems. You might want to write this in your homework section. And then we're going to practice 2 AP practice problems as well that are due for tomorrow that have more than one y in them. So what happens if I ask you to do implicit and you have like 2 y's? It has one extra little step in it, so we're going to go through that. So I'm going to get you guys to try for now, we're just going to do number 2 of the AP practice, which is like these ones. So number 2. Two says dy over dx equals, so the first derivative equals square root 1 minus 2y cubed. And they want d2y dy dx squared. So they just gave you the first derivative and want the second. So it's equally the same as if they gave you the first, the normal equation and asked for the first derivative. You just do the derivative of it, right? Pardon? So this is the AP practice problems. 3.2. Okay. Yeah.
So, if it's the second derivative, shouldn't it be y squared?
Nope. They write it as d2y over dx squared.
Oh.
It's just the format they use. They put the 2 in the middle. Okay. So, what's the first thing we're going to have to do whenever we have a radical?
But it's
Change it to a half exponent.
you technically still be writing it as dy dx, or you just write it as like y right now, because you're not doing it.
It's dy dx because it was dy dx in the first place. They gave us the first derivative. They didn't give us the y. All right. So how do we differentiate this? We're going to go derivative of this. What's the derivative of dy over dx? d2y over dx squared equals. What do we do? Bring the half down. We have to do chain rules. We do the outside first. So we do 1/2, rewrite to the negative 1/2. And then we multiply by the inside. The inside happens to have y in it. So watch yourself. So we're going to do derivative of 1 is nothing. And the derivative of negative 2y cubed is negative 6y squared times dy over dx. What do you do when you're finding the second derivative always? Using implicit. You go back to the original and put the first derivative in. Remember how I started that? Because everyone forgets that step? Only with implicit does this happen. In your normal second derivative, you just find the second derivative, you're good, right? Implicit, the reason why you have to insert the first derivative is because you have that y. Remember, all the rest are all just one derivative, or one variable. It's like x's or m's or u's. This one has y. So you have to remember this extra step for you. Put that baby in. So we're going to get 1/2. This to the negative 1/2, where is it going to go? To the bottom. The negative 6y is going to stay on the top. Negative 6y squared, sorry. And the dy over dx would stay on the top, which is this. So I just inputted this into here, and it stayed on the top.
Can you cancel this?
They're the exact same, so you can cancel them.
So when you insert like a radical back, do you suggest that you use fractions to get the actual radical sign?
Yep.
And then is it, and then can we simplify even more?
And then you can take a 2 out of both. I'm going to just write that. So now I can take a 2 out of here, I'm left with negative 3. A 2 out of here, I'm left with 1. So it's negative 3y squared, which is b.
Wait, how do we, how the one that's not
What's up? Yeah. What's the matter, James?
I don't know, I got lost something. I got lost something. I'm lost. I don't know where you got the 1 minus. I don't know how you got the one.
This is a negative exponent, so I dropped it to the bottom and made it a positive exponent.
Oh, okay, I see.
Okay, you guys are going to try this one next. We're going to do this one first, and then we'll do the other one. So we're going to do number 5 first. So 5 says, this is all AP practice problems, so I'm working on your problems for you. 5 says, find y prime if x to the 4 plus 4xy, which now you would be same as we've been doing, but now we're going to add plus 6y squared equals 12. So the difference here is I have 2 y's. We've never had 2 y's, correct? We have 2 y's. We've never had 2 y's. So we're going to end up with 2 dy over dx's, or 2 y primes, correct? Because when I do the derivative of the first y, somewhere in that product rule, I'm going to get with y prime. And when I do the derivative of the second one, when I do the y squared, I'm going to get a y prime. Okay? So I'm going to get 2 y primes. So let's just keep that in mind. It's a little bit, it just gets you an extra step. Okay? So let's just do the derivative, like we said. First step is always just differentiate the whole thing. We agree? And I'm going to use y primes because they asked for y prime. If they asked for dy dx, I would use dy dx's. Okay? So derivative of x to the 4 is 4x3. What do we have to spot with this?
They're multiplying.
There's a product rule. So I'm going to go in there and I'm going to put a dot. So we spot it. This is my f. This is my g. My f prime is 4 dx over dx, technically, but I don't have to write it. And my g prime is 1 y prime. So my f is 4x, my f prime is 4 dx over dx. By the way. And my derivative of y is 1 dy over dx, which we're writing as y prime because that's the notation they use. Right? So let's do the product rule. So we're going to get plus f, which is 4x, times g prime, which is y prime, plus g, which is y, times f prime, which is 4. And I'm just done that middle piece. Then I have to differentiate 6y squared. 6y squared. So what's the derivative of 6y squared? 12y to the 1. Yeah, dy over dx. And in this case would be y prime. And then what's the derivative of 12? 0. Watch yourself. A few of you will write 12. I do it the odd time. It's just... So, terms with y prime instead of 1. Normally we just add or subtract then divide, right? And we were done. What happens when we have two variables? So let's pretend I give you this. 4 plus 4x plus 4 plus 12x. Let's pretend that's what it was instead of y primes. What would you have to do first? Combine the ones that have the x's, correct? So what are we going to have to do first? Combine the ones with y's, y primes. However, they're not the same, right? So when we combine them, we literally just write them side by side. So we're going to go 4x y prime plus 12y y prime. Like I can't put them together because they're actually not the same term. And then everything without a y prime, I'm moving to the right. So I'm going to get this and this to the right. So I'm going to get minus 4x cubed minus 4y. So I literally just wrote the ones with y prime together and then put the ones without y prime on the other side. We agree? Does that make sense? What can I do now? What are we ultimately trying to do? Get y prime by itself, correct? Are we not trying to just get y prime by itself? Yeah.
Can you bracket the 4x y prime plus 12y y prime and then just take out a y prime?
Exactly. So at this step, you have to take a GCF of y prime out. So you take a y prime out of both terms. And then you're left with 4x plus 12y. Boy don't hand in his homework, but he knows how to math. Right? Exactly. That's what saved him all this time. Ability to do math. Okay, so how do we get y prime by itself? Just divide the bracket over. So if you do exactly what Andre said every single time and take that y prime out, you're golden. After this, it's really easy. It's the remembering to get the y primes together and take a y prime out that people get stuck on. They get to that step and they're like, don't remember what I'm supposed to do. Okay? So we divide the 4x plus 12y over. And then they'll just take a 4 out of every single one of them. So they'll go negative x cubed minus y over x plus 3y, which matches something. So they take the negative out of the top. It's going to be an A. So it matches A because they take the negative out and write it in front. They take this negative out and they go negative. Write these both as positives. X cubed plus y over x plus 3y, which is A. Nope. It's plus signs. No, it would have to be like an x, an x, an x, an x. A y, a y, a y, a y, right? Remember, the only way you can cross off when there's plus or minus signs is you can GCF something out and then cancel. Yeah.
Like when you think of negative out in front, I thought it was like when you were, like if you tried to put back in your house, you would put it wouldn't you?
Yeah, either the top or the bottom. That negative only goes to one or the other.
Oh, okay, that makes sense.
Yeah.
That's why I wouldn't be bothered.
Because if there was a negative out of the bottom and a negative out of the top, it would turn to a plus sign.
Yeah, okay, that's kind of confusing.
Yeah.
Okay.
Okay, you guys are going to try this one. Number 3. Number 3 says the slope of the tangent line, they want to find the slope of the tangent. That's all they want, the slope of the tangent. When I give you the graph, slope of the tangent line to the graph of x squared y minus xy cubed equals 10 at the point negative 1, 2. So you're going to have to do 2 product rules with y's. So do your product rules, do all your math like normal. Then your next step is to get everything with y primes on the left, everything without y primes on the right, take out a y prime, divide. So try this one out. Okay, so we're going to get f, b, So we get f, which is x squared, times g prime, which is y prime, plus g, which is y, times f prime, which is 2x, and then minus, in brackets, because you can minus the whole product rule, so make sure you do that, fg. So we're going to get f, which is x, times g prime, which is 3y squared y prime, plus g, which is y cubed, times f prime, which is 1, equals 0. Then I have my minus sign through. So I get x squared y prime plus 2xy minus 3xy squared y prime minus y cubed equals 0. So a lot of people will forget to distribute through. Then you have to get everything with a y prime on the one side. So you get x squared y prime minus 3xy squared y prime equals y cubed, added over, minus 2xy. Then you have to take a y prime out, and you're left with x squared minus 3xy squared. And divide it over. So y prime equals 2 cubed minus 2 times negative 1 times 2 all over negative 1 squared minus 3 times negative 1 times 2 squared. So it's 8 plus 4 over 1 plus 12. 12 over 13? D. Just kidding. Actually, kind of stayed okay.